Hey everyone, so funny story, I completely fell for it. We all did. Society universally accepted this one massive, totally unearned assumption. We thought that just because a machine is built to look exactly like us, it can finally do our chores. Welcome to 2026. We were promised an autonomous butler. We were sold the dream of kicking back on the couch while a sleek, futuristic android cooks a perfect medium-rare steak and seamlessly mows the lawn. But reality hit hard. Instead of a robotic maid, we ended up with a $20,000 chunk of metal that spends more time sitting in a charging dock than a teenager spends doom-scrolling on TikTok. We need to talk about why there is such a staggering, almost comical gap between what this machine can lift and what it actually understands. Let's break down why we bought the hype in the first place. Visually, Tesla's Optimus is a literal Greek god. The proportions are striking, the aesthetic is incredibly intimidating. But the real magic is under the armor. Tesla didn't just go to a hardware store and buy off-the-shelf motors to make this thing move. They custom designed their own actuators. Think of actuators as the robot's artificial muscles. They engineered these muscles for extreme torque density. Torque density is basically an engineering term for packing an insane amount of raw rotational power into the smallest, lightest package possible. Imagine trying to cram the power of a V8 engine into the size of a soda can. That is what we are dealing with here. Because of this, Optimus is terrifyingly strong. We've all seen the promotional footage. It can lift incredibly heavy industrial crates. It can drop into a deep squat with 200 kilograms of weight. Perfect form, ass to grass, not a single mechanical tremor. It is a masterpiece of hardware. But here is the brutal, unspoken reality of robotics. Building a strong, agile, heavily armored body is only about 10% of the work. It is literally the easy part. The result of mastering the body but failing the mind is what we currently have sitting in our living rooms. Optimus is a literal mechanical meathead. Think about it. Optimus is exactly like that one specific guy at your local gym. You know exactly who I am talking about. He carries around a gallon jug of water, he grunts way too loudly, he can bench press a Ford F-150 without breaking a sweat. But then you watch him try to figure out the touchscreen on a self-checkout machine at the grocery store, and he is just utterly helplessly defeated. That is Optimus. The physical hardware has the body of a Greek god, but its domestic skills rival a toddler hopped up on apple juice. This brings us to the cognitive gap, the other 90% of the robotic equation, the brain. Tesla tried to take a massive shortcut. They took their FSD, their full self-driving software, from their cars and essentially tried to port it straight into the skull of a humanoid robot. On a whiteboard in Silicon Valley, this probably sounded like sheer genius. A car AI is amazing at navigating the world. It sees objects, it calculates distance. Why wouldn't it work for a robot? Here's why. A car AI is incredibly good at navigating a very specific type of world, highways. Highways have strict rules. They have brightly painted lane markers. They have stop signs. They rely on predictable physics. A car is solid. A pedestrian is solid. A concrete barrier is very solid. Your house has absolutely none of that. Your house is an active war zone of weird geometry and chaotic physics. When a Tesla car is driving down the highway, its brain knows how to react to a solid brick wall. But put that same brain inside a robot in your bedroom, and suddenly it is facing a crumpled t-shirt on the floor. To a car AI, a crumpled piece of fabric does not compute. It isn't a solid obstacle. It isn't an empty road. It is a shape-shifting, bizarre anomaly. A car AI looks at a stray sock and
basically suffers an existential crisis. The software simply cannot translate the rules of the highway to the chaos of domestic life. Which brings us to a very obvious, mind-blowing question. If this multi-million-dollar AI brain is struggling this much to comprehend a single cotton sock, how exactly did Tesla release that insanely viral video of Optimus perfectly folding a t-shirt? Because you saw it, I saw it, the entire internet saw it. The robot looked flawless. Well, the truth involves a massive, carefully staged illusion, and it perfectly explains the exact science of why humanoid robots still walk like they are stumbling out of a dive bar at 2 a.m. We are going to uncover the man behind the curtain in just a minute. You saw the video. Everyone did. Optimus standing at a wooden table, delicately reaching for a black t-shirt, picking it up, folding the sleeves, perfectly creasing the fabric. It looked like magic. It felt like the autonomous future had finally arrived. But if you zoom in and look very, very closely at the extreme bottom right corner of the frame, you will see something hilarious: a human arm, moving exactly in sync with the robot. That was not artificial intelligence doing your chores. That was a high-tech puppet show. Tesla used a trick as old as robotics itself. It is called teleoperation. The robot was not thinking. It was not calculating the geometry of the fabric. It was just mimicking. Off camera, there was a real human wearing a complex VR headset and a pair of haptic sensor gloves. The human folded the shirt. The robot just copied the exact hand movements in real time. The brilliant mind behind the curtain was literally just an engineer in a motion capture suit sweating in a lab. Why fake it? Because programming a robot to fold a shirt autonomously is a literal nightmare. Our hands are absolute miracles of biology. We take them for granted. Optimus does have 11 degrees of freedom in its hands. That sounds incredibly impressive on a spec sheet. But without a brain that understands physical context, it is completely useless. It is operating tactile sensors with the grace of a wrecking ball. Sure, Tesla showed us it can pinch an egg without cracking the shell. That looks great on camera. But holding an egg is just basic pressure math. The sensors feel the resistance, the computer tells the fingers to stop squeezing. Simple physics. Fabric is entirely different. Fabric does not have a fixed shape. It bends, it folds, it collapses. When an AI looks at a laundry basket, its vision gets completely overwhelmed. Shadows look like solid objects, a wrinkle looks like a mountain range. The AI cannot predict how the material will deform when pulled. If you ask Optimus to dig into that basket and find a matching pair of socks, the physics engine will completely crash. The robot will have a literal system meltdown over a cotton blend. And this massive hardware-software disconnect gets even worse when you ask this thing to move. We have to talk about the legs. If the brain cannot handle a sock, the body definitely cannot handle your living room. You have probably noticed that humanoid robots always walk weirdly. They bend their knees, they hunch over, they take these heavy, flat-footed stomping steps. It looks exactly like a guy trying to sneak to the bathroom at 2 a.m. without waking up his angry wife. There is a very specific engineering reason for this. It is called Zero Moment Point Control, or ZMP. Think of balancing a heavy broomstick on the palm of your hand. You have to constantly shift your hand underneath the broom to keep the center of mass exactly supported. If the top leans left, your hand must move left. That is what Optimus is doing every single microsecond. It computes complex math to keep its heavy torso perfectly balanced over its wide, flat feet. Human brains do not do this. Human walking is actually a controlled fall. We throw our center of mass forward into empty space.
Then we swing a leg forward to catch ourselves at the last possible second. We have fluid, dynamic motion. Optimus does not. Even now, with all the fancy Gen 3 upgrades, it is locked in a permanent, terrifying shuffle. It does not flow, it recalculates. This works completely fine in a sterile, perfectly flat Tesla showroom. Those floors are spotless, they are mathematically level. But your house? Your house is an unpredictable war zone. A human living room is absolute chaos to a robot. Imagine the terrain: a stray Lego on the carpet, a slightly slippery throw rug, an uneven floorboard, a dropped towel. Any of these tiny obstacles instantly destroys the math of that zero moment point. One stray dog toy, and this multi-million-dollar marvel of engineering turns into a massive metallic tipping hazard. It is incredibly ironic. Optimus is designed to replace human labor, yet in almost every real-world test, you literally need 2 human spotters hovering awkwardly behind it just to ensure it does not faceplant and crush your expensive coffee table. So it can't walk over a rug. It fakes its laundry skills. It requires constant human supervision just to cross a room, which makes the massive, glaring elephant in the room even more absurd.
My latest
Elon
invention.
Musk stood on a stage and confidently
Cleanup
promised this thing would cost
Error.
less than
Balance
a car.
compromised. Alert.
Just 20
Cost
grand to
escalating.
own your personal
Malfunction.
robotic butler. But if you look at the real math, the hidden fees, and the insane ecosystem required to keep this thing running, $20,000 is just the cover charge to the most expensive joke in modern tech history. Let me show you what you are actually buying. You are buying a printer, but the ink costs your sanity. Elon's math sounds fantastic when he tweets it out at 3 in the morning. He confidently claims that Optimus will cost less than a car, just 20 grand to own your personal robotic butler. But that sticker price is a total financial illusion. Think about how tech companies operate today. You do not just buy the hardware and walk away. You subscribe to the ecosystem.
To get your Optimus to do anything beyond staring blankly at your wall like a haunted mannequin, you are going to need the software. Welcome to the Tesla Bot Plus AI subscription. Then you have to factor in the proprietary maintenance. Robots break constantly. When your vacuum breaks, you throw it out or buy a $50 belt on Amazon. When your Optimus accidentally snaps a titanium finger because it misjudged the density of your refrigerator door, you can't fix that with superglue. You are looking at a 4-figure repair bill from a highly specialized technician. And let's talk about the electricity bill. Powering an industrial-grade machine to clumsily shuffle around your kitchen draws serious juice. It's like running a commercial air conditioner just to microwave a Hot Pocket. Let's do some very basic math here. For $20,000 plus the monthly AI fees, plus the massive power draw, plus the inevitable repairs, you could literally hire a professional human cleaning service every single week for years. And the human cleaner will not accidentally punch a hole in your drywall because a weird strato looked like a hostile obstacle.
Yeah, the
So if
delivery
it
was
makes
on time.
zero
It's just
financial
standing
sense,
there now.
why are people actually buying this thing in 2026? Because we are firmly living in the status symbol era. Optimus is not a utility device. It is the new blue checkmark. It is the ultimate real-world flex for Silicon Valley tech bros. Picture the modern luxury living room, bare concrete walls, a massive gray couch, and standing in the
Behold, my
corner, an
ultimate
over-engineered
creation.
action figure
A
looking menacingly
flawless
futuristic.
fusion of power
You do
and
not buy an
precision.
Optimus to vacuum the rug. You buy an Optimus so your dinner guests can look at it and go, wow, you actually bought one. It's a $20,000 conversation starter that occasionally demands a firmware update. Which brings us to the actual
Robotic revolution. The one happening right under our noses, completely ignored by social media. While Tesla has been dominating the news cycle with flashy, highly edited videos, the other guys have been doing the boring, actual work. Look at companies like Figure AI. Look at Boston Dynamics. They are not building lifestyle brands. They are building machines that seamlessly move heavy boxes in real-world, chaotic warehouses right now. They are sorting engine parts. They are loading pallets. They figured out a crucial secret. Robots do not need to look like supermodels to be useful. They just need to work. They operate 24/7 in dusty, ugly environments without a single PR team filming them. While Figure AI is actively transforming the global supply chain,
Behold,
Optimus is
the
busy
future
hitting
is
the
mine
gym
to
and
command.
posing with a
And now,
Cybertruck.
a triumphant
It
leap.
feels less like a monumental
A minor
technological
setback, but
leap
victory.
and more
The
like
Empire
Elon's very
stands
own
eternal.
silicone-based midlife crisis. And that changes how we need to view the future of automation. The irony here is truly staggering. We built a machine explicitly designed to replace human labor, but currently, Optimus requires more human labor to maintain, supervise, and fix than it actually saves. You have engineers, mechanics, and spotters babysitting a machine so it can pretend to water a plant. It is a stunning piece of engineering trapped in a fundamentally useless existence. It is unequivocally the Olympic athlete of doing absolutely nothing useful. We were promised a helpful companion, a robotic butler to give us back our free time. Instead, Elon delivered a terrible roommate, a roommate who utterly refuses to do his chores, eats all your electricity, and insists on showing you his gains in the mirror. So I have to ask you guys, would you buy a $20,000 robot that can't fold your shirts? Let me know down in the comments. Do you think this is the clumsy beginning of a genuine robotic revolution? Or is it just a very expensive toy for billionaires? What other futuristic tech myths do you completely buy into? Let's talk about it. And hey, don't forget to subscribe, because unlike Optimus, I actually do my own work.